Hello, everyone, and welcome to the first day of Convergence 2024 by Comet. I'm Gideon Mendels. I'm the co-founder and CEO here at Comet, and I'm really excited to kick us off today. Thanks for being here and joining us for the third edition of Convergence. It's really amazing to see how many of you have joined the event to explore the next frontiers of machine learning, and so many familiar names coming back the second and third time. Within the next 2 days, you're going to hear 15 expert-led sessions, a panel discussion, and then a training session as well. Day one will focus on the latest machine learning application, tools, and processes, and leading data scientists and engineers will share their experience and expertise. And on day two, we will host 3 complementary workshops. A few things to help you make the most of today. If you haven't already, I encourage you to set up your profile here on the platform with all the details you would like to share. Having a great profile enhances your opportunities for really engaging conversations. If you aren't already a member of our Slack community, just click the Join the Slack Community button at the homepage and join us. This is a great way to keep the conversation going after the event as well. At the top of the screen, you can navigate to any part of the event. The Live Now section, which shows the main stage, the event agenda, your personal agenda, and community chat and more. You can always hit the home button to return to the main page. Join the conversation. You can click the live discussion button at the bottom right in the Live Now section and drop your questions for the speakers to be able to answer them live. You can also see the speaker's presentation slides attached as a document to each session. And don't forget, all of these great sessions will be available for on-demand viewing after the event. So you can come back here anytime you want and catch what you might have missed and rewatch your favorite conversations. And do let us know in the community chat if you have any questions or need anything at all. We're very happy to help. And without further ado, I'm really excited to get started. So let's do it. I want to welcome our first speaker, Jayeeta Putatunda. She's a senior data scientist at Fitch Ratings. Jayeeta will talk about decoding LLMs and challenges in evaluation. We're thrilled to have her with us today to kick off Convergence 2024. Take it away, Jayeeta.
Hello, everyone. Welcome to the session. Thank you for joining. My name is Jayeeta Putatunda. I am a senior data scientist in the emerging tech group at Fitch Ratings, New York. Like I heard somebody saying that QR codes are the new digital business card. So here's my LinkedIn QR code. Just in case you want to connect with me, go for a coffee chat, or have any other questions follow up to this session, please reach out. So let's get started. Today, my topic is decoding LLMs, challenges in the evaluation space. I'm sure all of you have heard about ChatGPT and the wave of AI revolution that it has got in our lives. I think people who are not in tech are also now interested and kindly slowly moving towards this phase of trying out how ChatGPT can reform their life, the products, and then the projects that they were working on. So today we're going to see how we can evaluate some of these large language models that looks a little black box kind from the outside, and then what are the major challenges in doing that. Okay, so this is one of my favorite charts that kind of shows the boom in the growth of LLMs. If you see in the x-axis, it just represents the year starting from pre-2020 when we only had BERT. And honestly, from my perspective, I still feel BERT is a large language model, even though it's not. But it gave like that sense of encoded decoder based approach that kind of gave us a lift from the models or the methods that we were applying before, like word2vec, doc2vec. And it was a pain. I've been working in this field for quite some time, and then developing models from scratch using those techniques and TF-IDF. It was very hard to kind of deal with issues like out of vocabulary words, not enough context, only trying to do semantic mapping without having any contextual mapping. And you see the billion parameter in the y-axis have exploded, kind of like where we started with BERT. We thought it was a huge model, but we already have Llama 3. And since I've put together this slide, we already have Phi 3, I think it's pronounced as, that Microsoft released just like, I think 2 days ago. It's a comparatively smaller model than GPT-4, but is performing very well in a lot of leaderboards. You can check out the Hugging Face leaderboard if you want to learn and look more on that perspective. So let's move ahead and see where we are. So industry adoption, right? So the academic and the industry phase is sometimes a little doesn't go hand in hand. So we see a lot of models coming out, but how do we actually put them into industry use cases is where I'm more interested, right? We want to solve a lot of business problems using some of those models, and doing so, we also need to make sure that we are in a state where we are not releasing products or like models without proper evaluation matrix, because that can lead to both reputational as well as monetary loss for big companies that's deploying it. So industry adoption, if you see, this is a great visualization I found in one of the Google blog. It says that it started from very basic problems that we were trying to solve, right? Like language understanding, question answering, summarization, code completion, and translation, which is one of the biggest areas in the entire NLP field that we have been trying to solve. But this chart by Cobus Grayling, please look up this blog. It's a tremendous blog. He has explained a lot of these zones in a very detailed manner. I found this very insightful, so I wanted to put this up here. Is that now the landscape has come a long way from that zone that we were just discussing in the previous slide. So that zone was zone 2, where we were solving very individual or specific problems in the industry use case, like embeddings, like classification, speech recognition, or translation, like I mentioned. But then there came multiple zones that kind of tried to go one step forward in solving some of these issues. So zone 3 were products from some of these big companies that were particularly focused on solving some of these problems by using some of the large language models that came out in that we saw in zone 1. So Cohere came out with Coral, I think Meta had BenderBot, then Diablo GPT, OpenAI's Whisperer, is all of falls in that zone 3. Zone 4 is where we see all these big companies actually building a much bigger model. So again, Google Cloud, AI 21 Labs, Anthropic. I'm sure all of us heard about like Bloom. It was a great model. And then zone 5 is where we are now seeing that, okay, given all of these large language models that has billions of parameters, takes a lot of memory, has resource constraints to put them into production, we need tooling, right? So that's where zone 5 comes into. So data centric tooling, vector stores. How do you store these thousands of GBs of embeddings when you try to pass a particular document, say through a tokenization format? So storing them in vector stores for easy search, for easy uh, um, doing question answering is like what we are trying to solve in the industry side. And then, of course, playgrounds and prompt engineering. We all know that there came a time when everybody wanted to be a prompt engineer, but I think all of us are prompt engineers, right? We have been doing this since forever, since we are doing Google search. We try for particular keywords. If the the list of answers that were retrieved were not up to mark, or we were not happy, so we would try different keywords. So I feel we have been prompt engineers forever, since Google search came out. And then zone 6 is again very a focused way of saying that using all these LLMs, using all these tooling, what am I trying to solve? So this is an area where you see very focused solutions where companies are coming up with to either solve for idea creation or content generation, and of course like flow builders and building a conversational search platform. So it's been an intense couple of years in the NLP landscape. It has completely transformed itself, and I'm very excited to talk to you about like how and where we are now in the evaluation space of it. Before that, I'm sure, I think I should have also put the phi 3 data here, but I just wanted to show it here that since Meta released Llama 3, they tested on MMLU, which is multi language understanding task, and then also they did GSM and math, which is like more of quantitative math based problems. You see that it, using its 8 billion parameter model, it kind of beat Mistral, which is an open source model as well, which had a 7 billion instruction parameter tuned model, and it kind of like worked very well. I think all the demos that I've been seeing in the industry space right now, Llama 3 is winning considerably, and considering people can start with the 8 billion parameter, I think that's where the more win is, because you don't want to use a very big model just for your POC or like building the initial solution. You want to see if that's working out or not, and then kind of move forward with bigger models. So I feel this is going to be a huge game changer for the open source community. So right, like I was saying, LLM evaluation is all you need, right? Because without that, releasing models into production, there's no path forward to it, and without a clear path forward, we're not providing any business value. So what are we doing? There's a great blog by Exploding Gradients. Please go check it out. I think they kind of put together in a very clear format that I was thinking about, and we will go through it one by one. So what were the traditional evaluation matrix, right? I put it all together just so that we can take a look. Word error rate, of course, right? When we were building models like using Word2Vec, word error rate was a very key one. So what was the reference number of like words that you entered, and what was the actual output entered? So the number of the delta in the number of insertions and deletions gave a great reference score. But that's not that useful in our current scenario, where we also want to understand the context and not only word to word mapping. And that's what exact match can be a parameter, or it can be a matrix that is like a, a very hard baseline, just to evaluate that if it can be mapped one to one word wise, right? If not, then I don't think this makes for a great matrix anymore. There's also blue score for language understanding. We evaluate the text based on how many n-grams it was generated. This sometimes works pretty well for smaller models, based on my experience, but you cannot just make your entire evaluation run, or based on only blue scores. And rogue is for more of a summarization concept. So good to have scores, but you cannot only use them in your final approach. So what are some of the other embedding based evaluation metrics that we can work through, right? So of course there's BERT score. I still feel for some use cases we do not need to deploy very large language models, and BERT or smaller BERTs, or very fine tuned use case specific BERTs like FinBERT, or Albert models as well, that has been fine-tuned on specific your industry use case specific data, can also outperform some of these large language models. The only caveat is that you have to have great quality data to train it on. Otherwise there's no way for a good apples to apples comparison. So in the BERT score, it's, as we all know, it's a bicoded encoded based approach. What is happening here is that we have a reference example, like say here the example says the weather is cold today, and the candidate example is it's freezing today. So if you think about this example for exact match, or for word error rate that we were discussing in the previous slide, we would get a very poor score, right? Because the weather and the cold, those two words are missing in the candidate sentence, but it actually means the same thing. It's just synonymous, and then some of the words are missing because it's not required. So this kind of situation, like I said, for contextual reference understanding, BERT score could be very useful. It does a pairwise similarity, cosine similarity score, and then finds the maximum similarity score that gives the final output. There's also mover score. So it also uses contextual embeddings to calculate the Euclidean similarity between multiple n-grams. And I love this example. It makes a lot of sense, because the system X, if you see the example, it says a guy with a red jacket is standing on a boat, and then the reference is a man wearing a life vest is sitting in a canoe. So you see there are multiple similar words that can fall into the similar vector space, which is like guy and man. Then red jacket can also sit in the similar vector space as life jacket. And that is the relationship that the mover score is trying to map. BERT score kind of falls a little short in kind of making that relationship work, but then mover score kind of takes into consideration. But in all of these scores, based on your use case, you have to do multiple checks and then verify, making sure that you have some good reference data to map it against. Some of the other language model based metrics are like entailment score. I like this very much because it kind of now we are moving from very hardcore standard matrix to something where we can utilize another language model to help us evaluate our own the output from our own language model. So entailment is like we're leveraging the natural language inference capabilities of another language model, say a bigger model than what we are using, GPT-4 maybe, and then you passing the output from our model to compare that with the ground truth. So here, NLI, which is natural language inference, we're passing two sentences like he was born in New York and he was born in NYC. It gives a high entailment score because New York and NYC actually belongs to the same. It's basically the same entity. This would have been missed in all our previous modeling score metrics, because if there's not enough context in the data to understand New York, and definitely the word error rate and exact match, the traditional outputs would have given us a very bad score for this. There's also Blueword. It's a very nice combine. It's like combining, the fully learned matrix from a large amount of synthetic data from a pre-training perspective, and then it was fine-tuned in some human rating. So this method uses the BERT methodology, and you can see in the example, like it says, the reference example talks about Bud Powell was a legendary pianist, and then the candidates were Bud Powell was a legendary pianist, which again gives you a one full score because it's the complete match. But candidate 2 and candidate 3, you see Bud Powell was a historic piano player. So it's still on the same concept, legendary, historic. Maybe they cannot be used alternatively, but it still means a similar thing, that the person was very well known. So it still gets a higher Bluer score. And then Bud Powell was a New Yorker. So it doesn't match anything with the reference, so then we get a negative Bluert score. But if we would have used the same example again with our traditional methods, we would get a lower score for candidate 2, because here we see extra words, like the number of assertions are more than the reference. That's why we would have gotten a much poorer score to a much relevant candidate answer. So that's a win over a lot of previously used traditional matrix. And then there's also question generation method, which is like we are first forming pairs and answer candidates questions from the candidate text, and then comparing and verifying them with the reference set of our questions. So this also needs you to have like a particular set of good solid human QA'd reference or ground truth, so that we are able to do this kind of matrix evaluation. So let's get into the LLM assisted. Some of these evaluations that I think there are 3 that I'll mention here. I have definitely applied one of those in one of my work, but these other 2 are mostly suggested in multiple papers. You can find the source code open source in GitHub, but we are still yet to evaluate. But if you look through the entire steps and the background understanding of how this process was created, I think it makes a solid sense, and it can definitely give it a chance. So GEval is something that's recently developed. It's a framework, and the paper, I mentioned the name of the paper here. It's NLG evaluation using GPT-4 with better human alignment. And we will talk about the human in the loop aspect in the later part of the presentation. But just to highlighting this, just so that you know that a lot of the LLM evaluations right now are coming with including human in the loop processes. So what is this process trying to say? So we have a task introduction, which is you'll be given one summary written for a news article. The evaluation criteria would be coherence, so 1 to 5. If it's grade 1, if it's bad, then 5, etc. And then using these 2, task introduction and evaluation, we ask the LLM to create a chain of thought prompt to get to a particular solution. So it's not that we are writing the evaluation steps ourselves. We are asking a large language model to write the ideal steps of evaluation steps given the task introduction and the evaluation criteria. Now, using all these 3 inputs, we give the prompt at the input context, which is the particular article that we want it to summarize. We also give an input target, which is the particular summary, and then we do the evaluation from there, finding the coherence score. As you see here, it's a weighted sum score, and then based on how the model marked it from 1 to 5, it was given an average score in the total framework. Please feel free to read this paper. It's very interesting. It highlights some of the challenges we have now and then is trying to solve in a very unique way. There's also GPT score. This is also like in the similar path, but it also performs the evaluation task in a little different way. It uses the conditional probability to kind of generate the target task instead of going in a very form filling way that we were giving exact steps in the previous method. There are no exact steps here. So that you have a task specification like generate a summary. We have an aspect definition. Now here's something that I want to highlight. So what's the difference between a relevant information and an informative information? Like say if you are an analyst and you want to try to find out about what Apple is doing in terms of its ESG commitments. Now, we all know in all marketing documents or our annual reports, we talk a lot about, or not we, like the companies talk a lot about what their initiatives were, what they did, what their goal is, but not necessarily that will be relevant to the exact ESG based information that you're looking for. So that's informative, but relevant will be the specific quantitative metric saying that, hey, we decreased carbon footprint by this percent and we're going to be carbon neutral by 2024. Just give an example, right? So that's the difference between informative as well as relevance. So that's why we separated this here in this method as like two segments. Then we have a template where we have a text and a TLDR summary. We have an evaluation sample. We also have a demonstrated sample by saying that, hey, if this is the given text, this is what is informative aspect of it, and this is what the relevance aspect of it. Then we use that as the input, and then the GPT score kind of gives us a score based on how informative it was or how relevant it was given our template, given our demonstrated samples, and then the task specifications. It's also a part of this paper. Please feel free to go and dig deeper in that for your understanding. And then there's LLM assisted. So this is a self-check GPT. Here, we are doing a little bit of different, a sample-based approach where we are using the LLM to do a fact check, right? I'm not sure if all of in which use case this would be most used, but sometimes like using or creating sampling answers may or may not be the best approach for your use case. But if you have like say tweets and you want to identify if this context belongs to that particular contextual tweet that you're comparing, or maybe doing a semantic similarity or a sentiment analysis, if that matches, I think this could be a good use case for that. Because here we are like passing the LLM's passage needs to have sentence level, right? So we are generating responses, sample 1, sample 2, sample 3, and then asking the LLM, does this sample support the sentence that we fed the LLM in the first place, given the original context, right? So the answer would be either yes, no, and based on the score, you see that here it shows how often the sentence supported by the samples. Some of them it showed no, some of them it said yes. So you pick up the yes ones and say that, okay, this is the output that I'm looking for, and this is what is most relevant or coherent for my output model. So that was a lot of concepts, right? Some of these are like in a part of the research paper is still getting deployed in particular industry use cases, or the code bases. I think the code base for all these approaches are open source, so please go and take a look in their respective GitHub areas. But if you are already applying different methodologies or choosing a metrics when you're building RAG-based approach for your use case, or maybe you want to fine-tune open source LLM using your industry use specific data set, what are some of the metrics that you can choose, right? So for RAG-based, faithfulness, contextual precision, and recall are very, very important. Understanding the difference between answer relevancy and contextual relevancy is the key to kind of finding an area where you are not basically you're differentiating between the answer that you're fetching or the exact answer that you want to match it to versus that did it find that answer from the correct context. That's also very, very important. Just going back to my previous example on the ESG report, or like a annual company report, if I just pick up the answer saying that, okay, Apple is spending this much money for its ESG from the annual report, instead of going to the actual ESG report, but it has more detailed breakdown of its investments. I think that gives you the contextual relevancy importance, that hey, I want to find the more detailed answer from the actual source, which is ESG report, that's more relevant than the actual annual report. And then also there's perplexity, that am I getting the answer in a very clear way, and it's grammatically and semantically correct, and the words belong to each other, right? And when you're doing fine tuning, it's like the model shouldn't hallucinate. There shouldn't be any data bias or toxicity that you intentionally or unintentionally might have introduced when you give the particular data set that you want to fine tune with. So these are some of the metrics that needs to be taken care of in the final stage. So what is the issue, right? Like we talk about that, okay, we have these many areas. I found this image very informative. I've highlighted the source here. Please go and take a look. It talks about that, okay, we can create or chat about any topic, we can answer all the questions, but underneath there is a lot of issues that we need to kind of be aware of, like are we doing any kind of copyright infringement, is the data safe, are we like leaking any PIIs or private information, can that lead to biases or hallucinations? And also the aspect of the environmental effect, right? Like I'm sure all of you read the report that MIT came up with. I think it was before the era of LLMs, and it talked about how much carbon emissions each model training takes. It's a huge, I don't even have the number on top of my head because it's so big. So we have to be very cautious and careful about the kinds of model we train. If all of us try to train our model from scratch, that's never going to happen. And we're gonna waste a lot of resources. So open source is the key, and the way that we leverage that and build on top of it is going to change the aspect of how we are solving problems today. So evaluation of LLMs with human in the loop is what I was saying. This is another fantastic paper. Please read about scale eval and how they are proposing the entire solution to be framed. Is that we have a question prompt saying that, hey, my friend's dog just died and they're really sad, how do I comfort them? And then we have multiple LLM submissions. In this case they said 2 LLMs, right? So 2 open source LLMs, the answers are like, here are some suggestions, and another example. And then you have a user defined criteria like helpfulness. You can choose from any matrix that we discussed in the previous slides. And now we create an agentic format, like a multi-agent debate. And sorry, I'm regressing here, but I want to make sure that all of you read the latest uh, what's called newsletter that Andrew Ng released. It talks about how in the next coming couple of years agentic AI development is going to be key. So reading and understanding about how to frame and create some of those is very, very important. And that's what this paper is also utilizing to kind of solve this problem. So we say that, okay, which submission is better, and with the multi-agent debate, if there is a consensus is reached, then we choose the agent's answer. If there's no consensus, then the human answer wins, and we go forward with our evaluation. So great paper. Please take a look at it, and feel free to I'm happy to jump into a call to discuss more about this paper. I absolutely loved reading this, and happy to chat more about it. So just wanted to highlight 2 other OS packages, like open source packages for your evaluations. I think if you're starting in this space, I think Ragas is a great place to start. You can import your own data set. You can if you have like an OpenAI key, you can utilize some of the Raga scores to get contextual relevancy, factuality, and answer relevancy. These are some baseline scores that you have. There are more. So please feel free to take a look. You must have your data set in the format of like say question, contents, answer. There's also deep eval, similar use case. It's also open source. Take a look at the GitHub. And then please feel free to reach out if you have any questions. This basically, you have an input, you have a retrieval context, and you have an actual answer and then you have a threshold score. Basically, that's how you create that entire matrix parameter. If it's the answer relevancy, and then why the score. So they also have the answer relevancy metric reason. So there would also be an explanation of why the score was what it was given. I also want to highlight the comment LLM ops standalone product that I came across. I did a little bit of testing as well. You basically can, have various levels of input. You can like check their relevance scores, and it's basically a back end great evaluation view of running all your LM calls and seeing the answers or scores in one place if you have no other matrix dashboard that you're working with. So that's all for my talk. I think I gave a rundown very quickly. If you have any questions, but some things to remember is that evaluation is all we need. I think we all read the paper. Attention is all we need, and I think we are in the stage where we have very concretely can say that evaluation is all we need. Bad data still makes your life harder to fine tune or instruction tune LLM. So data is still the king or queen, however you want to say. And then advanced LLMs, there's another third point that I want to highlight, may or may not be the best solutions depending on your use case. So leveraging open source, smaller models, training and fine tuning on top of that could also be a great use case. So that's where we are. Thank you for attending this session, and I'm open to any questions. Thank you very much.